partners and Scientifique friends, and thank you very much for joining us today. I'm Nicole Testa-Boston, the Deputy Director at Scientifique, and I'm glad that you are all able to join us this morning for our weekly Technology Tuesday webinar series. We've got an exciting hour set aside to talk about the Europeans' perspective and applications for future smart energy efficient buildings. So with that, I want to briefly introduce our speakers. Professor and Dr. Abdul Samad Sami. Alain is the Chief Research Scientist and Research Coordinator of Processes and Information and Communications Technologies in the Built Environment at VTT Research Center of Finland. Sami is also Adjunct Professor at the Hankin School of Economics in Finland. His research experience spans more than 30-scale international research and development projects. Project budget 500,000 to 25 million euros. Sami's research expertise spans information technology for construction, strategic road mapping, knowledge management, academic innovation, project management, and research coordination. He's authored in excess of 90 refereed scientific publications, including more than 10 edited books on IT and construction, project management, knowledge management, systems innovation, and open building manufacturing. Sami is listed in the Marquis Who's Who in Science and Engineering, 8th and 9th editions, and in the Marquis Who's Who of Emerging Leaders, 1st edition, and in the International Biographical Center's 2000 Outstanding Scientists of the 21st Century. He is fellow of the Innovation E100 Global Knowledge Leadership Network, and he's a co-champion of Scientifique's Element 5 roadmap area focused on operations and maintenance, and co-chair of Scientifique's Academic Council. Dr. Alain Zarili gained his PhD in computer science in 1990 from the University of Nice, Sophia Antipolis, and is currently working at CSTB as a project manager and head of the Innovation and Services Engineering Division within the IT and Knowledge Dissemination Department. His main fields of interest are programming languages and compilation, product and process modeling, rule-based languages and knowledge-based systems, distributed architectures and component-based software and services, and ICT for smart constructions. The division he leads in CSTB is currently developing methodologies and tools in the fields of ICT-supported energy-efficient buildings, ambient assisted living, information systems for asset management and risk-based management, and for the support of collaborative and cooperative work in construction. He's been and is still involved in many projects of the European framework programs, excuse me, and has been in FP5, the project coordinator of the IST ICCI cluster project and of the IST RoadCon strategic roadmap. He is currently active in the European Construction Technology Platform as well as the Energy Efficient Buildings Initiative, being one of the main authors of the ECTP Processes and ICT Focus Area Strategic Research Agenda and participating to the elaboration of the EEB Multi-Annual Plan for Future Integrated European R&D in the Construction Sector. He's currently coordinator of the REEB project, in charge of establishing the European vision and roadmap for future R&D in ICT supporting energy efficiency in the built environment. We are thrilled to have both of you here today, both coming from France and Finland. And at this point, I am going to turn it over to Alain to begin the presentation.
Yeah. Okay. Thank you very much, Nicole, and greetings from the whole Europe to all our American friends. Hopefully you can hear me very well. So as an introduction, just tell you that Sami and myself are, of course, very, very happy and proud to make this presentation, which is really trying to provide you with the current European perspective on the use of ICT in our future smart energy efficient buildings. In the next slide, I'm just going to provide you with an overview of the webinar. I will provide you with a quick overview of the REEB project, just to set up the scene about the work that we're going to present to you. And then Sami will introduce the context and vision industrial context and what is the RIB vision with respect to this industrial context, and also with respect to some societal context as well in Europe. Then we'll have a short slot for question and answers. Then I will probably run through some case studies that we have started to grab in Europe dedicated to ICT for energy efficiency in buildings. And then Sami will introduce to some new European research initiatives in this field. Then finally there will be another slot for question and answer, and then a very short introduction to how we can collaborate together in the future. So if I start now with the RIB project and directly to the project overview, the RIB project is really about establishing a European strategic research roadmap to ICT-enable energy efficiency in buildings and construction. So this is a European project which is really at the crossing of several technologies. The first one is, of course, ICT, information and communication technologies. And during the whole presentation, when I refer to ICT, it's really about information and communication technologies. Second technology, of course, is energy efficiency. And the third area is really the construction and built environment. So this is a coordinated action funded by the European Commission under the objective ICT for environmental management and energy efficiency. And the mission of RIB is really to identify, synthesize, and classify and get to a common agreement of the main problems, challenges, and finally roadmap related to the future development, delivery and use of sustainable and energy efficient facilities and buildings, and especially through ICT-enabled information management and decision making. So this is what is summarized in this slide, a vision and a roadmap supported by detailed strategy. There are mainly 4 objectives in RIB. The first one is really to establish a European-led community dedicated to the innovative use of ICT supporting sustainability and energy efficiency, and provide with this comprehensive set of stakeholders in order to discuss and fine-tune the vision and the roadmap. The second objective is about identifying the current state of the art. Should it be in terms of best practices, or should it be in terms of recent and ongoing RTD projects, so as to provide a reference basis for identification of SOTA in the roadmap. The third objective is, in the next slide, to establish a vision and then a roadmap that is as much as possible shared by all the key European stakeholders for ICT-supported energy efficiency in construction, along with some implementation recommendations in terms of future research to be undertaken under the European Commission Framework Program. And one of the achievements of this objective will be the realization of a book at the end of the day. And of course, well, the fourth one is classical one, achieve dissemination, training and education in order to provide awareness. Of course, this webinar is an example of such dissemination. Very, very quickly, in a nutshell, 8 partners, CSTB and VTT, but also Alain, which is a Spanish research center, the University of Cork, the Technical University of Dresden in Germany, the CEA in France, which is the French Agency for Atomic Energy, but indeed now for all types of energy, and eventually 2 industrial partners, Acciona, which is a big construction players in Spain and indeed in Europe, and Arup, which is a very well-known engineering company in the construction sector. In the next slide, the the key point here is just to provide you with a snapshot of the various areas of interest to REEB as a whole. I'm not getting into details, of course, of it, but definitely ICT is really at the heart of the figure that you can see on this slide, and is really dedicated to all the aspects of business models for in-construction design and integrated and holistic design for energy efficient smart buildings, intelligent control in smart building, integration of renewable energy sources, and all the aspect of energy management, should it be at level of the building itself, or even in the district, or even in the cities. So this is the main scope of the REEB project. What is expected from REEB is that hopefully it will be a key contributor to pave the way to some leadership in ICT enable energy efficiency, but also that it will help, I would say, worldwide to widen the take-up of ICT-based energy system and services in order to really contribute to future energy neutral and energy positive buildings and neighborhoods. And one of the key points is really that we expect to deliver and also in relationships with Scientifique and with participation from all of you, that we will provide a more holistic view on the need for integrated complex engineering ICT systems for energy efficient buildings. And I may be back to this point a little bit later on when I will introduce to some of the case studies that we have selected for presentation. So I guess that now I'm leaving the floor to Sammy to introduce to you the context and vision that we are developing in REEB. So Sammy, it's up to you.
Hello and good evening from Finland, where we don't have a shining sun, but snow is on the way. I'll run you through the context and vision of the REEB project, and basically looking at some of the background, what impact we can get from information communications technologies, our approach, and how basically we've set up the vision and its separate views. If we start off with a very simple understanding of the background, research today indicates that approximately 80% of energy use within buildings is basically during the operational phases. However, at the same time, design decisions influence about 80% of the energy consumption of buildings throughout their life cycle. So in short, this 80%, which we basically use within the building's life cycle, it's about 80% of that is impacted based on design decisions made earlier on. And last but not least, evidence shows that user behavior and introducing real-time control actually influences energy consumption by somewhere in the range of about 20%. I'm going to now just show you a graph, a pie chart really about a study which deals with energy consumption of reinforced concrete buildings throughout the life cycle. And again, we see over here that occupation, this is basically the usage days, accounts for about 79%, close to that. Renovation is about 5.5%. Demolition removal only 0.4%. And if we look at the manufacturing and the erection and the transportation parts, together they account for about close to 16%. So again, really not too much, with the main core basically being during the occupation of the building. If we look at what's happening in our industry today, we realize that unfortunately energy performance today is regulated by loose regulations. This is primarily the case in places like Europe, where we have national standards and regulations, and we're only now approaching a European-wide regulation on this, on how it can be regulated. Furthermore, and sadly, market is typically driven by lowest initial cost. So if I offer you a building at lower cost, you will perhaps take that as opposed to one with better value. And this is in particular the case in today's economic situation. From the positive side, there are things which are coming into existence, such as climate change, we're all aware of, is now driving more robust and stricter regulations. This should lead to better energy savings and consumption mechanisms also. awareness of energy and actually, realization of different operational costs are creating new business incentives towards sustainable solutions. These, at the same time, also could, for example, contribute to lower insurance costs for buildings. We've identified different impacts of information communication technologies on buildings. For example, if we were to move forward in the short term, we need to assure compliance to certain regulated minimum energy performance levels. And these basically take place in the design and renovation stages. If you recall a couple of slides ago, I mentioned that 80% of the impact of design decisions actually influences how we actually consume energy later on. So again, when it's designing or doing the design of renovations, we need to pay a lot of emphasis on this. When we come to the medium term, here the focus is really towards real-time operational control and then empowering the user to control how they use and operate different activities within a building to optimize energy usage. In the long term, we believe in heading towards a holistic optimization of the built environment and focusing on the generation of energy, its use within buildings, balancing the energy across buildings, and then feeding excess energy back into the grid. And all of this, we believe, will be driven by whole-time performance. Within the project, we've tried to apply a rational methodological approach. If you look at this slide, we believe that we started off with an idea that we need to have information and communications technologies for energy-efficient buildings. So the first scope was identifying the vision. What would be the anticipated or desired or hoped for impacts of using this new knowledge for the industry? Based on this, our aim is to identify a set of research and development topics. These are basically required new knowledges and technologies that would facilitate reaching the vision. Once we have the topics, these are translated into research projects whereby we actually go by to develop, test, and demonstrate some of these new knowledges and technologies, and then we get back into industrial implementation. This is basically taking up this knowledge and technologies into the industry. And of course, as we all know, a vision is just a point in time now, so it keeps on evolving, and naturally, based on what happens in the industry, there comes about naturally a new vision. To put it briefly, we've identified our vision to be that information communications technology will contribute to the energy efficiency of buildings, mainly through design tools, automation control systems, and decision support for various stakeholders. And then we've broken it down into what we could have in the short, medium, and long term. In the short term, we need to have technologies that will be used to ensure that both existing and new buildings meet current and emerging requirements for energy efficiency. Again, this would be more like complying with regulations which may come up. In the medium term, we will use information communication technology tools to enable life cycle optimization of design energy management during the operational phases of a building. And last but not least, we believe that new information communications technology will not only enable but also support new business models and processes that naturally in today's environment will be driven by energy efficiency. Within the REAP project, after several iterations, well, let me come back to that in a moment. Some of the aspects of the vision, what it will basically do is that we believe information communications technology will have a transformational role. And here we've basically broken it down into 4 clear components. One is heading towards a life cycle approach where we talk about interoperable model-based tools. And these will essentially assist us to optimize whole life performance of buildings. We are also heading towards smart buildings, and by this we basically mean buildings that will be smart enough to control themselves and respond proactively to external environmental conditions. At the same time, we believe that through modularization, bringing some concepts of manufacturing, we can transform the construction industry to be more industrialized. And here we believe that industrialized solutions will facilitate the configuration of flexible buildings as well as retrofitting existing ones. And last but not least, we believe that we will be able to come up with new business models and regulations, which will be driven by user-perceived values. And naturally, these will contain a performance-based approach to improve the performance of buildings, and we will have tools for performance measurement, validation, and last but not least, holistic decision-making. Within the project, we basically have identified 5 key research areas. They include integrated design and production management, intelligent integrated control, user awareness and decision support, energy management and trading, and last but not least, platforms for energy information management. And we'll come to some of these later on. If we look at combining these research areas with a life cycle perspective, you see something like you have in front of your screens at the moment. Our key research areas are what we have in the vertical columns, and typical building life cycle stages we have on the horizontals. So starting from programming and design, then we have activities such as manufacturing, construction, renovation, demolition, and last but not least, operations and maintenance. What we see through the horizontal movement is leading towards sectoral applications, and what we see coming down vertically would be generic information, what we believe to be cross-sectoral research results. We're still working on this, and what this will actually translate to is going to be something like this, where we see a very clear mapping between an information communications technology view, that's what you see at the bottom, the platforms and technologies for energy sharing, integrated design production management, intelligent control, energy management trading, and user awareness and decision support. And then we see what impacts these would have from a construction perspective. So, it's a combination of 2 views. And over here we have, for example, integrated design mapping onto integrated design production management, as is the case for industrialized production. That also maps over there. High-performance buildings, they're enabled through intelligent and integrated control. We have operations and services managed through energy management and trading, and life cycle performance management managed through user awareness and decision support. And all of this is, of course, managed through governance and business models. What this will eventually translate into in terms of a roadmap view will be something like this. I believe some of you may have seen something very similar, and whereby what we do is that we have a current state, and then we have short, medium, long-term actions, which then lead to the vision. Again, this roadmap is a snapshot at any given point in time. So what, for example, we have in the short term, that is something which is almost ready for industry to take up and use. What we have in the medium term is something which is currently, for example, being developed and will be ready for the industry within the next few years. And what we see in the long term is something which is now being researched, will later, after a couple of years, be developed, and maybe after a couple of further years be actually taken up by the industry. We are driven by objectives. These are the second green row you see at the top. And of course, these are based on different market trends and drivers. That's the topmost row you see. And of course, at times we do get limited by different barriers. Now this is how the roadmap will look like. Each of these boxes, or a combination of these boxes, will actually be translated into what we call implementation actions. I'm not going to go through detail of this template, but this is just to show you how we aim to capture each individual action. Some of the key elements of relevance may include the time to industry. Is it in the short, medium, or long? What type of industrial problem are we trying to solve? What are the technological objectives? The approach, how we will go about solving it? What are the required competencies? What will be the tangible results? Who are the people who are actually required to carry out the work? The resources required in terms of costs, tools, duration. The beneficiaries, these are the main people who will get the benefits of the results. Exploitation in terms of how will the results be provided to the users, who will use them and how. We have industrial impacts, what benefits could we get out of the use of the results. And last but not least, we have some follow-up actions if and when required. This pretty much concludes the first phase of our presentation, and me and Alain would pause for a while to take any questions if you have any at this point.
Yes. Sammy and Alain. We do have one question. Individual wants to know, what is the purpose of regulations as opposed to allowing the free market to incentivize the general market through higher value, lower operating costs, and lower financing costs due to value?
I'll take that one. I think it's a very good question. Thanks for it. It's the same as saying that, if we have 20 software vendors and we say it's a free market, you go about and do whatever you want, there will never be interoperability. We will never be able to communicate across buildings in this case. So what we do through regulations is we identify a minimum level of enforcement. And of course, once you have that minimum level in place, on top of it you have the free market. So the market can go definitely beyond it, offer more value to people, and they can then go about and procure it. But we do believe that we do need a minimum level of regulation, because if there is no regulation, we will not see change, and people will actually buy what is cheapest on the market, especially in today's economic climate. Our intention basically was to quickly run you through about 7 case studies which we've collected at the moment. There are many more which we've also collected, but aren't really showing over here due to a lack of time, and in the end we'll also invite you to contribute your case studies where and when relevant. The first case study we actually tried to look at covers some CAD software we have in Finland for energy efficient building design, and this basically supports our key research area on integrated design and production management. The key objectives here basically be having building services systems, the design and analysis, and then to have all building systems in the same drawing, or let's say pieced together to run a complete functionality test. The developed tool basically supports design of HVAC systems, electrical design, comfort, and of course energy simulation. In terms of used technologies, it's all model-based. I mean, this is happening pretty much everywhere, and especially in Finland and Europe, and I know now in the States also. And then they're using IFC 2x3 as a standard. Again, this is pretty much open and can change also. Another important aspect of the application of this case study essentially is that they deal with component catalogs, which include thermodynamics and different flow behaviors. What this basically in the end provides us with is it's an ability to integrate different energy efficiency calculations and other parts of holistic design. And this basically avoids an overload of doing different things with different tools just to get a proper energy analysis. And we also believe that through skilled users we can get significant gains in terms of the total energy consumption of the design buildings. Again, this relates pretty much to this 80% I was talking on prior to this one. Our second case study, which should now pop up on your screens, basically deals with the deployment of smart meters in France, sorry, not Finland. And this is related to our key research area on intelligent and integrated control. What they've done over there in France is that they've broken it down into different categories of users. For consumers, it provides real-time awareness of energy consumption. For the producers, it provides better management of when the peak loads are, and also allows management of energy across different networks. And then when we get into grid managers or utilities or energy service companies, this gives better knowledge of real electricity flow. Also allows the capability for flexible tariffs and then holistic service concepts. This could lead to energy audits and better predictive maintenance. There are a range of technologies available. I'm not going to really run through them as we don't have time, but you're welcome to ask us these later on. And then if we look at the impacts we've had through these smart metering deployments at a consumer level, this has led to reduced electricity consumption based on users having real-time awareness of how much they're using where and when. At the producer level, it helps to reduce the production costs because they're able to manage peak loads, where and when, and actually from a a grid manager's level, they have about 35 million kilometers covered by different utility agents each year, which are now saved because they're able to do remote online maintenance of these smart meters. If we go to case study 3, that's more on building energy management systems, covering our research area on energy management and trading. Again, here we try to get into modular, easily customized and configurable tools, combine predictive control with intelligent HVAC, getting into intelligent lighting, again, something pretty popular over here, and then enable condition and performance-based maintenance. Again, a range of different information communications technologies, such as embedded sensing, automation and control, which of course includes the monitoring of different sensors. We are also getting into automated switches and controls for microprocessing, and then as an enabler, we have very strong decision support algorithms. In terms of impact, what we get is interoperable connections and protocols which allow holistic provision, operation, monitoring, and maintenance of systems, various control and service software running on a common integration platform, something we like to call a building operation system, and last but not least, we have the capability to holistically manage different building services, such as heating, cooling, lighting, air conditioning, and security, of course. The fourth case study we have is more related to power price signal devices and changing behavior through real-time pricing. This allows us, for example, to empower customers to make smart power consumption based on information provided to them, will lead to stronger differentiation in terms of transparent pricing versus usage-based billing, and then hopefully we hope to establish a technical platform for further improvement in this.
Okay, gentlemen, ladies and gentlemen, I'm back, I guess.
Great, Alain, you take over.
Okay, where are we exactly? Okay, case study number 4. That's it? Can you hear me?
Yes.
Okay, so did you describe case study number 4? Okay.
Just go through case study 4, Alain.
Okay, great. So case study number 4 is really trying to concentrate on the aspect of user awareness and decision support, and especially changing behavior by real-time pricing. And this is about really giving the empowerment to customer to really take let's say the right decision, right between codes, in terms of their own energy consumption, and also supporting, of course, energy providers to deal with peak times. So for the end users, the main interest, and especially, for instance, considering this in connection with smart meters that have been presented, I guess, by Sammy in case study 2, are really to be able to access to, for instance, some detailed invoice about their real energy use. The opportunity, of course, to change the invoice, I would say, nearly in real time, just the way we do it now for with our mobile phones in case. And of course, at the end of the day, to have an improved energy consumption, which is really make easier thanks to having these consumers being aware about the energy use, and to make them responsible as well with respect to this energy use. So the applied ICT that, of course, we are trying to develop is all the aspects around display, and one can imagine very, very different kind of technologies. Communication infrastructure as well, that should leverage in near future the network to really provide very, very detailed information data to the display.
and develop one or several algorithms to generate a simple, easy to understand tariffs. And one can imagine as well, for instance, having some kind of global optimization techniques to take into account various parameters that could be defined differently from one day to the another by the consumers in order to modify the way they want to get more or less energy or electricity. So the impact has been the impact of the one that I referred already previously. In the next case study, we are really concentrating on all the aspects of what will be the platform what will be the underlying platforms and technologies. So this is one example among others, which is probably very well known by all of you who are involved in all the aspects of building information models, the famous beams. But what we do believe is that we will have to elaborate on top of models, for instance, like the IFC. We'll have to elaborate ontologies to provide formal representation of what we want to achieve in terms of energy efficiency. So to have formal representation of energy efficient building concepts and all the relationships between those concepts, so as to provide solution to information brokers to make possible accessing to the building information. One of the key requirements that is ongoing is probably to integrate in the future the various energy-related subsystems of buildings together, despite the fact that they may use different communication protocols, but also application protocols. And if we want to really achieve in the future an integrated and holistic control, to have integrated and holistic control and monitoring schemes to reduce the energy consumption and CO2 emission of buildings and districts, we will have, of course, to rely on those building information data models. So the impact is definitely, of course, to avoid mistakes, incoherencies, to support interoperability, to enable more detailed analysis about energy efficient buildings, while at the same time relying, of course, on the design phase, and to facilitate, at the end of the day, the maintenance of installation and the renovation of those installations as well. The two next case studies, maybe I'm going to very quickly run through because they are referring back to previous categories that we have been dealing with. So the case study number 6, I'm a little bit in trouble in getting it.
Alain, do you need Sammy to advance the slide?
Yeah, so sorry. So, well, the case study 6 is really about holistic energy and facilities management, and some developments that are especially ongoing in Europe, in Germany and in Ireland. More in Germany in terms of best practices, and in Ireland in terms of research prototypes, and which are really focused to the facility and the asset managers, the operator, the owners, in terms of stakeholders. So once again, the applied ICTs mainly are web-based user interfaces, but that are relaying or interfacing with data warehouse technologies. And those technologies are already ongoing and under experiment in Germany, and they are applied, where they are more, I would say, developed in Ireland as research prototypes. And in the next and the final case study, This is another example of clean, which is dedicated to integrated design and production management, which is about clean room operation and pre-manufactured intelligent facades, which is a spatial experiment in a very interesting platform in Germany, which is called In-House 2, and I really invite you to get more information on this platform because this is a huge ambition in Germany to have many demonstrators and many experimentation of smart buildings, including energy efficient smart buildings in energy, based on what the various manufacturers can provide in terms of new type of equipment, optimizing energy consumption, and also how the way they can be integrated in the built environment. The applied ICTs in that case are mainly building information modeling, business process modeling as well, as far as manufacturing is concerned, production planning, and all, of course, the aspect of tools and data exchange standards for energy information sharing. I'm sorry to have been out for some time during this presentation of the case study, so maybe Sammy quickly introduce the fact that at the time being in REEB, we have right now collected more than 60 case studies, so those one are just examples and synthesized examples, and that of course you may have full access to all those case studies if you join the international REEB community. But I will be back to this point later on at the end of the webinar. So now I'll let Sammy quickly introduce to you to the new European research initiatives. So Sammy, it's up to you.
Thank you, Alain. I hope you can see the slides. And there is apparently some delay in them getting through to you. What I'd basically like to run through you is a couple of examples of some emerging research initiatives which we have in Europe, covering roadmaps, intelligent use of buildings, energy efficiency control in hospitals, and then connecting different industrial sectors. As a first example, I hope this comes, should be there at your end pretty soon, if not there already. It's an example from a project called StratCon, which we ran a couple of years ago. And amongst different roadmaps, one of the ones it came up with was on intelligent construction. And here the main ambition was, how do we get a totally disconnected home, first of all, integrated to allow connectivity. This was through what we call integrated automation and control. And what you see in the green second column going downwards are just some technologies. We're not going into those details. And once we have that, we allow a capability for remote diagnostics and control, basically relating to serviceability. And once that's the yellow column in between, and last but not least, we move towards an ubiquitous home, allowing context-aware seamless configurability, or what we call adaptability. To perhaps showcase this in some type of example, so the first step really could be that, if there is a leakage somewhere in your wall, the system informs you that there is a leakage. Once it gets to be a bit more interactive, your service provider could know when there is a leakage. They could try to remotely fix it or stop it. And in the last case, if there is, for example, a leakage, the system could self-heal or switch off water, inject some particular type of glue just to go about and close it. So for us, the transition was basically first towards an electronic home, then towards an interactive one, and last but not least, towards an ubiquitous home. One of our major projects ongoing today is called Intube. I hope you can see some portions of the slide now at least. There is a website at the top right-hand corner. And here what we try to do is we try to make intelligent use of a building's energy systems. And essentially what we do is we try to integrate recent information communications technologies to support intelligent building and neighborhood management systems. And essentially how this is done, I hope you can read what we have in the slides. We capture information from building databases. This could, of course, be something like a BIM model. And then the building, for example, that transmits information back into the system using intelligent sensors, information, for example, related to the temperature, humidity, occupancy, lighting, energy consumption, etc. It's also connected to the facility manager, who can get information about the energy demands of the building, to control it, to regulate it, etc. And then if you look at the user, they again have access to different consumption and condition information. What are, for example, the indoor air conditions? What is the current or historical energy consumption, current demands, and how they can actually play around with it. So I would invite you to visit the website of this project just to see how it's, some of the emerging results. They've actually come out now a couple of months ago. The next example I'd like to show you, I hope it's coming up on your screen now, it's basically more of a demonstration project called HOSPilot. And that deals with intelligent energy efficiency control within hospitals. Again, there is a website where you could see this. And over here, what they're trying to do is to prove basically that we could reduce energy consumption through different mechanisms. We're basically using lighting control over there, and to regulate this based on the requirements in terms of the building, the people, and different, for example, how much lighting, when and where do I need in the operating theater or in the rooms, etc. At the moment, we're exploring 3 pilots in basically separate hospitals working under normal conditions, and then just to see how through technology we could leverage better use of energy. There are quite a lot of consortium members involved, and one which I'm sure most of you will know of is, of course, Philips. We're actually using their different lighting solutions provided by them in this project. Last but not least, this is just a snapshot of what we've developed just to see how we could connect different initiatives and basically industry sectors together. We see a combined merger, for example, smart grids, which enable dynamic tariffs, smart metering, consumption forecast, and energy trading, with, for example, smart buildings, whereby we can get data of different manufactured components and then do some further work over there, smart lighting, enabling some lighting control, and then when we get into smart manufacturing. And around all of this, we believe we have enabling and supporting information communications technologies. We're going to pause now, and Alain and I would be happy to take any questions at this moment if you have any.
Sure, great. Thank you very much, both of you. One question came in. There's a group here in North America called the Continental Association for Building Automation, CABA, and they have a tool called the Building Intelligent Quotient Rating System. They're wondering how can their members who have global operations participate in what you all are doing using that tool. I guess first maybe are you familiar or know about that tool, and then if so, how could they engage?
Sure. We've been aware of their initiatives, and actually the CABA roadmap, it was one of the things we have been and we do continue to use as some background solid research material. I think in the follow-up section we have on this, actually, Alain will go through on how CABA or others could actually participate within the REAP community and gain access to these results and actually go about and influence the results in terms of what could be different actions we need to undertake within Europe under our roadmap. Alain,
we have been following the CABA initiative and road mapping work since indeed the time of Stratcon, because CABA is definitely one of the best examples of road mapping, of successful road mapping from our point of view. So we are very, very keen to work with them, definitely.
Great, thank you. A couple more questions here. I'll try to go quickly because I see we're running out of time. What role do you see energy disclosure programs like the Buildings Directive in the European Union, or ASHRAE's Building Energy Quotient Program, or any other disclosure programs for that part, What role do you see them playing in the overall use of energy in buildings?
Yeah. Yeah.
We really have an audio delay here. I apologize.
No, but sorry, but I've been now in trouble, a little bit in trouble with my phone. So I've not heard all of your question. I don't know if Sammy heard it, and if he can reply to it quickly or not.
Sure. I think such initiatives, they set the clear benchmark on what others need to follow. And although I sometimes use the word as bare minimum, I don't think it should be taken for the word. It's a defined standard below which we cannot afford to go to. And naturally, over time, there would be changes and improvements on these. And I do know that, we're trying to get in more such directives whereby there is actually a push from regulatory bodies for energy providers or building manufacturers to actually get their act together to provide us with better, more environmentally friendly and energy efficient solutions.
Okay, 2 more quick questions. From your experience, how do you think, or how will you evaluate BIM adoption in Europe?
That's an interesting question, I guess. It's very, very different from one country to another, to be honest. It is really right now, I would say, taking off in France, but still slowly, too much slowly from my point of view. It is as well in UK. I do believe that BIM has been definitely adopted, for instance, in the Nordic countries more than in some other countries, just like Germany or France, for instance.
If I may chip in Finland, we're starting a new initiative. I think it should hopefully be rolling early next year. And that basically talks about BIM for business. And basically bringing, BIM to the business world in a language and form which they can actually understand and use. And we had a workshop today, and just to quote an example, we realized that we already have the technology. We don't really need much more on the technology side. It's more on getting the right people to be using the right tools in the proper way. Of course, I think in the Nordic countries, as Alain has said, we have been very successful in BIM adoption. And I guess we're seeing that trend now gradually increasing globally. Again, it's a bare minimal standard or mechanism through which we need to communicate. And when I say standard, I'm talking about, being it a DWG, a DXF, or an IFC, or whatever you may call it. But in essence, BIM is more of a concept we should go about using.
I should probably add, however, that in France standards are really pushed because of the large player, the big players, contractors, for instance, in France. Where on the other side there is, for instance, very few architects still today using beams or using even IFC. But well, there are fundamental, there are key progress anyway in using the digital market in the construction industry. So we have good hopes and great expectations about the fact that, well, let's say within 2 or 3 years, it will be generalized probably.
Great, thanks. And quick last question, is there an academic or graduate student level of membership in the International REIB?
What do you mean exactly?
If you are, well, I think probably the assumption from this individual is that there's a cost to join the REIB committee.
No, there is no cost. No, there is absolutely no cost. It's totally free to read the international REIB community.
Okay, so you will take graduate students as well?
Yes.
Yeah.
Okay.
More than welcome.
Great.
All graduate students from American universities and research centers are very welcome as well.
Great, thank you. That's all.
If somebody's interested, they're welcome to actually come to France or Finland and just work with us on these projects. They're more than welcome. But maybe I'll hand it over to Alain so he can just run through some very quick,
Yeah,
I
very
think,
quick.
basics on how you could, collaborate or work together with us.
Yeah. So back to probably what is the conclusion of this webinar in terms of collaborating together. We have imagined that there are several ways of being part of the REAP community in terms of either following the outcomes of REAP or sharing best practices with us or be part of our book and really working on the book with us. The first point is really that we would like at least you to join the community. As I mentioned, this is definitely free of charge. It's totally open. You have nothing to pay. What we just want to have, of course, is to have some, let's say, basic registration. And when joining the REAP community, and you can do it on the web address that is put at the bottom of the slide, then you will just fill in a very short form where you will mention if you want to receive regular progress, newsletter publication, if you want to get preliminary information and draft deliverables in order to react against those preliminary outcomes, to receive potentially invitations to workshops. Well, of course, as far as Europe is concerned, I guess that this is a long trip for our American friends. But anyway, the idea is really that you can choose your level of involvement and potentially commitment in working with us in REAP. So this is a first point. Then, in terms of really collaborating with us, you can help us collecting case studies. As I mentioned, we have already collected more than 60 best practices and case studies, but we would like to get more. Why not trying to get more than 100 best practices and case studies? So if you are interested in that you are joining the REAP community, then you can send us your case studies, and we are investigating the way we can have some competition if you enter before the 15th of December. So we will vote for the best practice, and we will try to give as much publicity as possible to those best practices that have been selected as the best one. Then you can be part of the book as well. If you are ready to write your own corporate vision, I would say, in a few words, if you want to describe shortly your company vision and outline running or plan activities in the REAP field, of course, which is the crossing of ICT, energy efficiency, and the construction sector, then you can, of course, fill in a template, and you can also appear in the foreword of the REAP final book to be published by the European Commission if you want to provide us with one page signed by your company representative with a photo. So this could be a way, of course, to also collaborate with us in REAP. And last but not least, of course, you should feel free to contact us at every time. There is the REAP website, which is indicated in that last slide. And you have, of course, all the information to contact Sammy or myself if you want to get more information about how joining the REAP community, some other information as well. So anyway, thank you very much on behalf of myself and Sammy. And I would like to take this opportunity to warmly thank Nicole as well for having organized this webinar. I don't know if there is time, if there is some room for a very final question, but, well, it's up to you, Nicole, now, I guess.
Thank you very much, Sammy and Alain. We have actually run out of time and run out of questions, so I think that is good news, but I do want to remind everyone, in fact, I think I neglected to mention it at the beginning, that we have recorded this webinar. We'll be cleaning up the audio and posting it on the Fiatech website under our media library, where we actually archive all of our webinars, later this week. So it should be up, if not later today, later this week, and you can access both the slides and the audio from that website. So Please follow up with Alain and Sammy. We also have information with those web links on our website at viatech.org. And I just want to thank both Alain and Sammy for taking the time this evening over in Europe to give this presentation, and apologize for the technical difficulties.
Thank you very much.
Thank you, Nicole.
Bye-bye.
Bye-bye.
Okay, bye-bye.